Hello and welcome back to Chemistry Made Easy with Distinction Medic. And in the course of today's video's lesson, I will be discussing on a special topic in chemistry, which is named to be chemical combination. In this particular video's lesson, I've made it really easy and understanding. Okay, in this particular video's lesson, I will be sharing with you the interaction between elements. What is the bond that is binding elements? Like example, like sodium chloride. What is the bond that is binding a sodium chloride together? Which is a metal. What is the bond that is bonding a metal atom and a non-metal atom? What is the bond that is between them? What is their interaction? Okay, in this particular video lesson, I've made it so easy and understanding. Okay, if you haven't subscribed to this wonderful community, do all by clicking the subscribe button to this channel and like and comment and share, and also turn on the notification button to this channel in order not to miss any subsequent videos lesson. Let's jump right into the work. Now, before starting, we must first move to an aspect which is named to be octet rule. Octet rule. Now, what did octet rule state? Octet rule is the ability of an element to fill both innermost and outermost shell. That should be there. Is the ability of an element to complete both innermost and outermost shell. That should be noted. Now let's move to what is called chemical bonding. Chemical bonding. You have chemical bonding. Now we have various type of bonding, which are electrovalent bonding and covalent bond, which they are the most important one. And we have various which are coordinate bonding, um, metallic bonding, hydrogen bonding. Now let's list it. You have the electrovalent bond, valent bond. We have the covalent bond. We have the coordinate or co-ionic bond. We have the metallic bond. We have the hydrogen bond. And also we have the van der Waals force of attraction. Okay, that should be there. Now let's take it one by one. We have electrovalent bond. Now, the main principle of electrovalent bond is the donor atom principle. Okay, is a donor atom principle, which there is a complete transfer of electron. And also, electrovalent bond can also be defined as the bond that exists between metals. This particular bond exists between metals and non-metals. This particular bond exists between metals and non-metals, okay, by the transferring of electron. Okay, that should be noted. It exists between metals and non-metals by transferring of electron. That should be noted. Now, the donor atom in electrovalent bond must be a relatively big size, and it must be a metallic ion like sodium with the atomic number of 11 is a metallic element. So the metallic element is going to lose an electron in its valence shell or the outermost shell. We have the electronic configuration of sodium to be 281. It's having a remains of one electron in the outermost shell or the valence shell. Now, this particular element, which is a metal, will loses one electron, okay, to become a positive charge ion, which is known to be a cation. Okay, now this is the equation. Now, when sodium metals, when it loses an electron, when it loses an electron, it's going to give a positive metallic ion. Now it has become saturated. Now I've told you before that all elements, their aim is to become saturated. They don't want to be reactive. They want to be saturated. Okay. Now it has attained what is called stable configuration, which is also known to be octet group or octet configuration. That's what it. Now the donor atom or the acceptor, let's say chlorine. Chlorine is the acceptor. When chlorine is a non-metal, okay, so it's going to gain an electron from a metallic ion, okay. When it gains an electron, it's going to be chlorine minus, okay. When it gains an electron, now let's use sodium chloride as an example. Now sodium chloride, the combination, the coming together of sodium and chlorine becomes sodium chloride, okay. It's also known to be a salt. Chlorine will give sodium chloride. You can see now sodium is with the sodium is with the sodium plus chlorine will give sodium chloride. Now sodium is with the electronic configuration of 281, and chlorine is with the electronic configuration of 287. You can see. Now when this metallic element loses an electron, you can see it's a positive sign. So that means it has lost an electron. So when it transfer this electron, one electron to this, is going to give when a sodium metal transfer an electron to a non-metal, so it's going to give attain 2,8, which is known to be neon. Neon is with the electron configuration of 2,8. So you can see it has become saturated, it has become stable, because a neon gas is a stable gas. Okay, you can't see neon reacting with any other element. You can't see argon reacting with any other element. Okay, when this gain an electron, is going to give 2,8,8, which is known to be argon. So that is simply the explanation. Okay, now let's draw the electron cloud. Okay, for sodium with the atomic number of 11, in its innermost shell it contains 2 electrons. In the outermost shell it contains 8 electrons, and in the valence shell it contains a 1 electron, just 1 electron. Now for chlorine in the innermost shell it contains 2 electrons, outermost shell 8 electrons, and the valence shell have a 7 electron. 1, 2, 3, 4, 5, 6, 7. Okay, when this transfer electron is going to give this, when it transfer an electron, it's going to give 2 electrons in the nano shell and also 8 electron in the outermost of finishing. So it has attained a stable configuration. Okay, now for chlorine, it's going to give you 2 electrons in the innermost shell plus 8 electrons in the outermost shell plus another 8 electrons in the outermost shell. You can see it has attained a stable configuration. That should be noted. That should be noted. Okay. Now let's move to the properties of electrovalent bond or ionic bonding. Let's move to the properties. The properties of electrovalent bond. We have the properties. Now, electrovalent bond contains anion, but they do not contain molecules. Okay, that should mean that they have high melting points and boiling points. That is second keynotes for electrovalent bond, because the dissociates completely in water, they can conduct electricity. That should be there. Okay, and also they occurs mainly in organic compounds, and they are not soluble in organic solvents, which are benzene and all likes on organic solvents. Okay, and all likes. That should be the properties. Okay, now let's move to the next one, which is known to be covalent bond. Covalent bond. Covalent bonding. Okay, that should be noted. The main principle of covalent bond is the sharing of electron between two the same atoms. Okay, is the share of electron within atom of the same, let's call it, of the same type. Okay, covalent bond is also defined as the sharing of electron between non-metals, just non-metal. You can see it differs from electrovalent bond. Electrovalent bond is the bond that exists between metals and non-metals by transfer of electron. But for covalent bond, it involves the sharing of electron between non-metals. It does not include metals. Okay, that should be in there. Now, for covalent bond, we have covalent bond. We have two chlorine atoms. You can see two chlorine atoms are of the same type. You can see they have the same type because they are both non-metals. So chlorine atom which have the electronic configuration of 287. You can see. So when two chlorine atoms, then during the electron cloud, we have 8 electrons in the outermost shell, and also another 8 electrons in the outermost shell. Another 8 electrons in the outermost shell. Now, another chlorine atom is there. 2 electrons in the outermost shell. 8 electrons in the outermost shell. Another 8 electrons in the outermost shell. Now, when two chlorine atoms want to share an electron, now it becomes, when sharing an electron, it becomes 8 electron, 8 electron, 8 electron. We have 2 electron here, 2 electron here, and 2 electron here. We have another 2 electron, 8 electrons, 8 electrons, and also we have another electrons, 2 electron. You can see they are sharing the same electron. They are saying the same electron. They are sharing the same electron. You can see it's simply the explanation for covalent bond. Now let's move to the properties of covalent bond. Now, covalent bond they contains molecules and they do not form ions. Second, covalent bond do not conduct electricity because they do not dissociate completely in water. They do not dissociate completely in water. That makes them to be a non-electrolyte, and they do not conduct electricity. Now, the third one, they have a low melting point and boiling point. Okay, that should be on there. That should be there. Go find all that properties of the covalent bond and electrovalent bond. Let's move to next, bonding. Now, the next bonding will be in another section of this video's lesson. Okay, do well to watch all my videos here on YouTube. My videos here on YouTube are very explicit. Please go watch other videos on my channel. Okay, thanks for watching. Don't forget to like, subscribe, and share, and also turn on the notification button to share and all that, not to miss any subsequent videos lesson. Love you more. Thanks for watching. See you in the next video.